class. Today we're going to be learning about the periodic table and how it is designed to help us be able to tell more about the elements. So kind of starting off, we need some foundational vocabulary. You know, it's summer, so our minds might be a little fuzzy. So an element is a pure substance that can't be broken down into anything else. Elements are made of subunits called, anybody know? What's the smallest piece of an element? An atom. Great. And then atoms are made of three different parts. What are they?
Protons, neutrons.
Protons, neutrons, and electrons. Good. Okay. So protons have a positive charge. Where are they found? What part of the atom?
In the nucleus.
In the nucleus. And then what else is found in the nucleus with them?
The
Neutrons. So protons and neutrons, P's and N's, those are in the nucleus. And then our electrons are where?
In the electron cloud.
They're in the electron cloud. So they're going to be kind of orbiting around the nucleus in this space. So we're going to use something today called a Bohr model to talk about how those atoms are made of. And for a Bohr model, what we're going to start off with is kind of a nucleus in the middle. I like to draw it as a cloud so we don't get it confused with our energy levels. We're going to put our protons and our neutrons in the nucleus. Then we're going to kind of build our electron levels, our energy levels around that by drawing circles around it. Now, the ones that we're going to do today are going to have up to 4 circles. And on the first circle, y'all probably already know this, how many electrons can we put on the first circle?
2.
We can put 2 on the first one. How many on the second one? 8. How about the third one?
8.
Okay, do we know past that?
8.
18. And then 32. Okay, so what we're going to kind of do today is we're going to work together to make a Bohr diagram for every element 1 through 36 on the periodic table. It's going to work out kind of cool in the end, but I do want to show you kind of with my little models up here how this is going to work. So on your table you have bright colored index cards that have the name of an element and its symbol. You have copy paper. So you're going to take the index card and glue it to the top part of the copy paper in the corner. Like so. Y'all will be glad to know I picked the highest one. I picked the hardest one. So, okay. Once you get your element drawn there, you're going to start with your nucleus, and this is going to be your blue dot. You're going to put it in the middle of your paper. So there's blue dots for each element, and that is all that we're going to glue on. Now in our blue dot, we need to write the number of protons and what else goes in the nucleus?
Neutrons.
Protons and neutrons in that nucleus. So does anybody know how I tell the number of protons? Look at your little cards on your table. That might give you a word bank to kind of look at.
The atomic number.
The atomic number is equal to the number of protons. So atomic number equals protons. And we also said that the neutrons go in the nucleus. How do we know how many neutrons to put in there?
It's supposed to be like the same or close to the same.
Okay, it's going to be close to the same. Give or take up to 3, 4. Okay, this is the one where you actually have to subtract. So you're going to have to take the mass number minus the atomic number. And that's going to tell you the number of neutrons to put in the middle. So my element is krypton, and its atomic number is 36. Now what does that tell me? Where do I need to put the number 36?
Proton.
That's my proton. So right here up on my card, my colored card, I'm going to put protons equals 36. And in my nucleus, I'm going to put P plus equals 36. My neutrons, I'm going to have to subtract. So I need to do my mass number, which is my bigger number. In this case, it is 84, minus my atomic number, which is 36. Anybody want to pull out a cell phone? Okay, 48. And I'm going to put my neutrons in my nucleus as well. So I'm going to write these numbers in 2 places. And all I have left to figure out is my electrons. How do I know how many electrons to put in there?
It's the same amount of protons.
Good. It's the same amount as the protons. Now, can anybody think of why we would want our protons and our electrons to be equal?
There was an imbalance of them.
If there's an imbalance, what's it going to do to that atom? It's going to make it have a charge, right? So normal atoms like to be balanced. They like to have the same number of positives and negatives, and so that's kind of where we're going with this. So to do my electrons, it's going to be the same as my atomic number again. So the atomic number is the protons and electrons. So for my krypton, that is also going to be 36. And then I need to start putting those electrons on there. These little rings that you've got on your table, these are templates for your energy levels. So you trace the inside of it for your first energy level and then the outside of it for your second energy level. Krypton will not be the neatest one we have done. And then you can use the markers to put your electrons on. I think it works best if you try to space your electrons kind of evenly. So my first energy level I can put 2. My second energy level I can put 8. 1, 2, 3, 4, 5, 6, 7, 8. And that gives me 10 so far, and I need 36, so I got to keep adding. So I'm going to get my bigger circle, I'm going to add my other circles here. And if you have one that has all of the energy levels on it, then you will have to overlap your card just a little bit, but that's okay. We'll still be able to see it drawn on there. And so I'm going to put 8 more. 1, 2, 3, 4, 5, 6, 7, 8, and that gives me 18. And to get up to 36, I need 18 more. So I'm actually I'm following this pattern right here: 2, 8, 8, 18. And this is going to be the highest one. You guys won't have to deal with the 32 today. So we're going to put 18 electrons on this one. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And that's going to give me my finished board diagram. So I'm going to give you guys a little bit of time to work on these at your table. There's like 12 per table, so that works out to be about 3 each that you'll end up doing. And then when you get them all done, just kind of lay them to the side, and we're going to use them like all together as a whole class to put together the periodic table in just a minute. So I'm going to let you guys get to work on that. I'm here if anybody has any questions.
Oh, okay.
Come on, Ben.
It's been a while.
Well, at least I retaught it to you before I could have just come in here and been like, Lee Parker, I taught you this 2 years ago. You got this, right?
I mean, I just had chemistry, but I don't remember nothing from it.
That's basic on body.
There's something.
left mine there.
Like which one goes on right to a circle? Mr. Nichols, what goes on circles? That's right.
So it's a test.
Yeah. I knew, I just don't think she was paying attention.
Okay.
You know, she's in a younger grade or whatever. I don't blame her. Seniors like me should help her out. Yeah, I got 27 left.
So you're going to subtract the two numbers.
Slightly. That's not good.
Yeah.
So not the good. It's not. Yeah.
When you get to upper level science classes, like hydrogen usually gives away its electrons, and so you'll hear hydrogen referred to as a proton. And they say a proton, and you're expected to know that it's well, you won't need it because you only have one electron. So. I just.
Both of them.
So I'll have what?
If you use the markers for the dots, like really big and here and then
Christmas time.
I needed
so two of them will go on the first ring, and then you'll need another ring for the rest of them. So the circles need to ring.
The circle. They can only do two. Oh my goodness.
How did you do the class?
What is it?
What is happening to my
You remember
glue?
what to do now? Okay. So your atomic number over here goes for your protons and your electrons, and then find your neutrons. You have to subtract those two. Just the atomic number. The atomic number is the protons and the electrons. So those are both going to be 20. Yeah. Yes, because it's 20 minus 20 is 13. Yeah.
This is a marker. I've had it in my hand so long. Yeah, something like that. 17.
Ms. Nichols,
Yes.
don't they have to sit a certain way whenever they, like whenever I run out on the outer ones, do I have to put them a certain way? Or does it matter?
If it was a higher level class, yes, but
Yeah.
we're just trying to figure
put
out
'em all
where
out?
the electrons go for right now.
I freehanded that.
One, I accidentally put one out there, but I exited out one, so they should work fine.
It's okay, because I bet on the next one you won't have to ask any questions at all. The next diagram.
I forgot the numbers though.
So sorry. I got one. I got one. Yeah, but I haven't seen you in a extended environment, so.
Do I look different or something?
Yeah, I'm used to all the other reds now. I'm used to it. Where you
I
live.
think that's my
Disgusting picture.
they ended up making too much like you said. I had to start thinking of something.
It kind of rains. It kind of rains down on the chin sometimes.
They're not all always the same.
Didn't drive through there.
You just happen to get
And you need people that you need that need
this
mechanic
one,
work done.
titanium, see it's 22 and 48.
You people who are good at breaking stuff.
Yeah, I got it.
It does look like they kind of pick the bigger numbers. Okay.
Oh no, I'm 31. What? Yeah, and there. Can tell us the entrance when you guys are
The first row gets 2, and the second row gets 8, and the third row gets 4. So you're gonna start awesome. So you got 2 and 8, and 8 got 18, so it's on your outside level. So get up to
I'm trying to get this mess. Can't switch colors. That works.
you understand one?
And all he said is that it can't. The short.
We have the harder one.
We gotta make them look good, you know. I'm gonna need it after 2 weeks.
My 8th grade science teacher, like,
Yeah, but I know what I'm doing when it comes time to do it.
really,
Except he's also
all
rehearsal.
9 weeks, like, we would just take on and have to do like 24 hours.
Makes her
And he
leave the
would make
next
us
year.
do like the ones
How many people
that
do you think you Joseph?
like we try to get us into the radio with like something
I know one
electronic.
of
Enough circles.
Technically, that was a combined effort. She did deserve it.
Oh man.
We didn't get to choose between them.
That's the better one.
I might have messed up.
What did you do, Joseph?
I drew it there instead of there.
Nobody will know if you're not putting your name on it.
I think the glue was covered up.
No, it dries clear, Joseph, come on.
What about blonde? What color does it dry? Blonde.
Never used it, can't tell you.
It's also like very little. Of course, they could that exists.
Really? So I just made you do it.
Yeah, and then my two are also Calvin.
I'll take off the plate.
Oh my goodness, I put 18 on it, but 17 on this. That's not fair.
Like I said, nobody's gonna know who they are because they don't have any.
I'll be super serious.
I won't tell anybody. You have the next to stand right on their head.
I'm fine with that.
See, this would be the part, like, this is an actual class. This is what I would call, like, your independent practice. Like, where I'm actually going through and kind of assessing and correcting mistakes. So this is a learning process. This is not just, like, a test. So, you're
What's for
good.
the missions or
Huh?
what's for the missions?
This is that I'm trying to get hired on. Yeah. Are y'all out? Y'all are out. I'm gonna hand y'all one from another group.
In that case, we're definitely out.
Oh, you got one to do?
Oh, I have this one. I think that's it.
Sorry, Ben.
I like to stick it down to it. It sticks to the
Have you got the hang of it now? Are we feeling
It
confident?
sticks to the floor.
What is here? No, no.
But like, my hearing's not good.
You're gonna put them in order?
Y'all are gonna put them in order.
And they just go in the order of the
It's like a
colors?
giant puzzle. Yeah, y'all are gonna build a periodic table out of these.
It goes by the atomic number, doesn't it?
Yes, they do. And then they're gonna have to figure out where to start these rows and where to skip spaces.
Like the first one's like hydrogen.
Good. Get us started.
And then like after that, I know you
Do
skip
y'all
on
have any
those.
more cards that you want to know?
I don't think so.
Okay, I'm gonna bring you some of those.
Sir.
Let me get to somebody else's stuff.
Yeah, take a piece of paper. Please. Yeah. And thank you. Please and thank you.
That's okay. There's some other backstory.
Oh.
That's great. Well, that's one of the things straight on the.
The goal is being accomplished.
Ms. Nichols. I need
A blue dot.
yes, ma'am.
Do y'all have any extra blue dots?
We were supposed to do what Monday.
There we go.
Does that matter requirement? So if you make the whole picture negative, shouldn't we just put on not putting stuff on paper? Because they would be negative, so wouldn't it be taken away from the paper?
So you want me to bring you a whole bunch of next time?
Yeah.
You're like the fourth person to make a mistake, so no problem.
Oh, cause she didn't Do we have to do 4? Cause I don't, they're not.
No, it didn't come out completely. What you got? So when you do 8 on this row, then I'll make 18. So you're gonna have 3 more circles, but 19, 20, 3 more electrons on.
Okay guys, as we finish up all of our board models, our next task is to put those in order and try to build the periodic table out of them. There's some questions that I want you to think about as you're putting these in order. First of all, what is constant about the way these molecules are built? What can you use to put them in order? Some sort of order. I also want you to think about the actual structure of the atom. How many electron shells did you have to use for your electrons, and how many valence electrons are there? Those questions, if you let them kind of bounce around in your head, will help you get everything in order. I'm going to volunteer this table to be like our project table, so if y'all help me like clear that stuff, maybe push it down to this end or something. And y'all bring your elements over here and work together and collaborate, and let's see what y'all can come up with.
You got a picture of like,
Well, I might want to move the chairs back.
I forget your name. You guys like hydrogen, helium, that's all.
I don't think that's she said that's how No, she said that's how periodic table. Who has hydrogen?
Why are you putting hydrogen first, Josie?
Because it's the smallest one.
It's the smallest one. Which number tells you that it's the smallest one?
The atomic number is 1.
Okay, the atomic number tells you that it has the fewest protons, okay?
What is this?
I think I was getting next.
It has 4, so there's one that has 3.
There is.
Who has, what is it? What's his name? There's one that has an atomic number of 3 somewhere.
Look for number 3. Okay, we got it.
This is 5. This one, that's what it is. 5, 6. 7, 8, 9, 10, 11. That's perfect.
Where do you stop at on the first row?
Who has sodium?
John Lee Parker's question.
First row goes to neon. So it goes on.
I don't remember where it stops.
It goes over here. Oxygen's over here. No. Carbon. Wait. No, these are over here. There's like a big gap in between them.
No, not right there.
Where's the gap at?
Why don't y'all do the next row and see if that helps y'all figure it out. So y'all know this one stops where? This row stops where? What's the last one supposed to be on this row?
Well, neon's a noble gas, so it's on here with helium.
Right. What is
But
special about it that makes it a noble gas?
it has a complete 8
Okay.
electrons.
So it has a full outer shell. So everything that has a full outer shell so far is in this row over here, right?
This one.
What do y'all notice about that first row over there? What's developing there? How many do they have on their outer shell?
1.
One. Okay. So let that kind of be y'all's guide and help y'all as y'all build that second, y'all build that third row. So neon was 10.
So that one has 7. This one should have 6.
Mm-hmm.
5. This one has 5 electrons. 1, 2, 3, 4, 5, 6.
I think we probably miscounted that one.
This one should have 5. This one should have 6. Wait, what?
messed up.
You're
Like,
going
that's X'd out.
backwards.
Oh, yeah. So Evan should have what?
I think we messed up now. 1, 2, 3, 4, 5, 6. It should have 6 altogether. So it should have 7 on the inside. Here, let's correct them as we go. So y'all, I don't know who did these, and we don't need to know that, but this is a learning opportunity for us. Some of us, when we were doing our electrons, forgot about those first 2 when we were adding them to the second one. So like this one, since it has 1, 2 already on that first one, we're only going up to 7, and we already put 2. So we only needed 5. 1, 2, 3, 4, 5. So we need to get rid of 2 of these. And then on this one, it's kind of the same thing. We need to get up to 6. We already have 2, so that means this second energy level only needs 4 electrons, because 2 and 4 is 6. So we're going to get rid of some of these extra electrons, okay? So learning experience, now we know, right? Okay. Now, how are we doing on our third row? 11, 12.
Who is 13?
13.
Right here.
Okay.
Who's 14? Who's 15?
The next one would be 18.
This one would be the last one on the row.
18. It's argon right here.
Yeah, this one has a mess up.
That one should have a 7.
I think this one has a mess up too. I think that's supposed to be 6 on that, so it's
It should be. It should be 6.
X off- X
1,
off
2, 3,
two on that.
4, 5.
So it's off 2 of them?
Yes, ma'am. Then 5, 4, 3.
Okay. Why are you putting that one back over there, Joseph?
I feel like there's a space.
Look at the one above it.
Yes, ma'am.
So you already got beryllium up here, and it has 2 valence electrons, right?
Yes, ma'am.
And that one has 2. So we want to keep the 2s in a line together.
Yes, ma'am.
I'm just trying to give y'all space to do that 4th row down there. 'Cause now it's looking too serious. All right, 4th row. Let's have it. Last one down here is what, Lee Parker? What's the last number we got?
18.
18. So we need to start with 19 down there.
That's yours.
There's 19. We're down here. 19, 20, 21.
Who's 22?
23. 25. That's not right.
Yeah, it doesn't go.
See, this is where the
Well, this one should have.
What was y'all's red flag about not laying? Which element was that?
iron.
Well, about not laying iron down there. What was your red flag? What told you that doesn't go there?
It
doesn't
has
have
8.
Okay.
So that's where the.
But is
supposed to
8
have
not
18.
full for that one? Right. 18 is full for that one because we're on the 4th energy level now, right? So we're on the 4th row. So it's supposed to have 18 at our full one. So our one that has 18 on the outside, that's going to be our noble gas this time.
So this is where.
So y'all are on 25.
And then.
Can we skip them?
You got more table down here, Joseph.
Yes, ma'am.
How many did this one have in it?
25.
I'm talking about the last out there. 1, 2,
I think it
3,
is
4,
7.
5. Okay, well, it's in that last layer, so it don't be Who has one that has 18 in the last
It's
one?
gonna be on the last
So like the
one.
biggest one we have, what is that?
It would be the one that Miss Nichols did, right? I had 18 in the last
It'd be like
I have a bunch
krypton.
that have 18 in the
Let me
last
see
one.
it.
one. It was krypton.
Yeah. So this one will go down here. So if that one's 36, then 35,
That's 35.
34, 33, 32, 31, 30,
It's 30.
29, 28, 28, 27, 26.
Okay. Now step back and look. What can we tell about the majority of our elements by looking at what column they're in on the periodic table?
How many valence electrons they have?
Okay, valence electrons. What are valence electrons?
What's in the outside circle?
Okay, so we've been using that word. I don't think I explained what it meant, so I'm glad y'all have figured that out. So valence electrons are the one in the outside shell. And the reason that these valence electrons are important is because they're going to determine what kind of bonds the atom forms. Is it going to form ionic bonds or covalent bonds with which type of elements? And so the column that it's in tells you how many valence electrons it has. What does the row tell you, like going across this away? What do you notice about the ones on the top row versus the ones on the second row versus the ones on the third row?
How many circles I have?
Right, how many circles they have. What do you call the circles?
Energy level.
Energy levels or electron shells. Great. There's a couple of different words for this. So you guys did a great job with that activity. If you would return to your seats for just a second. We're going to fill in this periodic table so that you'll have a record of this for your notes and the test that you won't actually end up having. So make sure everybody at your table gets one of those, and we're just going to talk through the things that we discovered and write it down, essentially. Okay, so look with me at the top little bubbly sheet on your periodic table. What is that pointing to? The top little cloud looking one. What's it pointing to? The columns. And what did we say that the columns tell us? How many valence electrons? So here's what I want you to write in that bubble. I want you to write column tells you how many electrons are in the outer shell. If you're really comfortable with valence electrons, you can go ahead and write valence electrons there. So the column tells you how many electrons are in the outer shell. Okay, and that bubble is pointing to some blanks across the top. So how many valence electrons did that first column have? One. How many did the second column have?
Two.
Okay, and then we're going to skip over to the column with boron. How many did they have?
3.
They had 3. If you guys look over here at our periodic table again, then you would see that boron, aluminum, and gallium all have 3. So number those all the way across except for that very last blank. Instead of writing 8, I want you to write, because they didn't all necessarily have 8, did they? They were full or complete. Right, so on that last blank, write full or complete. Okay, the blank on the left-hand side is talking about the rows. What did we say the rows tell you? The number of what? The number of energy levels. So in that little blank, I want you to write row tells you the number of energy levels. Left-hand side.
This?
Yeah. Row tells you the number of energy levels. Okay. On the far right, it says the energy level will hold. What do you think I might be talking about there?
How many?
How many electrons? How many electrons does the first energy level hold?
2.
2. How many does the second energy level hold?
8.
8. How many does the third energy level hold?
8.
And the fourth one holds?
18.
And this one holds?
32.
32. So those numbers are going to go in those blanks to kind of go down the side of your paper. So you're going to write 2, 8, 8, 18, 32 to remember how many electrons will fit in each energy level. Okay, the box down there with all the X's around it, I designed that for you to write down your formulas so you can remember how to tell the number of protons, neutrons, and electrons. So I want you to write that the protons are equal to the atomic number, the electrons are equal to the atomic number, the neutrons are equal to the mass number minus the atomic number. So basically this right here should go in that box with all the little X's and zigzags around it. Our very last little section to fill in is over there on the left at the bottom where you have to label that box on the periodic table. So the very first blank there is pointing to that big number, 277.028. What do we call that number? Do y'all remember?
Atomic number. Wait, which one?
Atomic mass.
Okay.
What are you talking about?
How do we know that that's the atomic mass and not the atomic number?
What are you talking
This
about?
one right
Because it's the biggest. I mean, it's
All the atomic
It's
numbers
the
are in order.
biggest is the biggest clue, the fact that it's the biggest. It's also a decimal, and atomic numbers don't come in decimals. So I want you to label that 227.028. Label that mass number. Another name for that is atomic mass. You might see it written either way. And there's a second line there because I want you to write that that is always the bigger number. Some periodic tables rearrange them so you can't remember it by where it's located. Some periodic tables round the nearest whole number, so you can't remember it by just knowing it's a decimal. The fact that it's the bigger number is going to be your biggest clue. So mass number or atomic number is always the bigger number. Okay, our next arrow, if you look just below that line, it's pointing to actinium, which is the element name. So please label that element name on your next blank. Okay, and the next line down is pointing to AC. Does anybody know what we call that?
Symbol?
That's the symbol. Good. And then the very bottom blank is pointing to the very top number, that 89. And what is that called?
the atomic.
The atomic number. Good. So now you know where to find that atomic number and the mass number on your periodic table, so you know how to find the number of protons and neutrons and electrons. Okay. Our last activity for today is to kind of figure out where this fits into the bigger picture of the world and God's creation. So I've hidden 3 separate Bible verses around the room, and y'all are going to look for them. Each group needs to find one verse. Once you find your verse, you're going to talk about how that verse relates to our lesson for today. I want you to kind of brainstorm and write down what your group says, and one of you is going to read the verse to us, and one of you is going to kind of summarize your group's thoughts on how that verse relates to our lesson today. Okay? Mark, get set, go. Y'all can find this easy. Summer found theirs easy.
Check behind that garbage can over there.
Yeah, so that one came in.
Y'all can use some of this blank copy paper that's kind of on your
Kind of speaker and stuff.
Y'all can use some of the blank copy paper on your table in order to be able to jot down your ideas. Okay, jot down your ideas.
More about wisdom found in the earth, by understanding and establishing.
Come on now. I'm messing up.
She was to write why we think it connects.
Yes. What's the connection? Why did I pick that Bible verse for tonight?
I say, he knew what he was doing. And it's all inside of
He's right.
he knew what he was doing.
Rice doesn't have to talk. Somebody else can talk.
I can't spell.
I feel you. I completely feel you.
You know what it is? You can see Adam. Like, is that what it's saying? My baby understands.
I had something.
I think that's what it's saying. It's saying something like you can't see something.
Read the very last 4 words and see if that helps.
You never forget my opinion.
Just make this.
No, I guess, I mean, I hope that's what it is.
How's it going?
Joseph said the first common sense of his life.
Is that what it is?
Okay.
Is that like a good
That
thing?
works.
Oh, okay, there we go.
Sounds good to me.
That works.
But who can? So we can't see it. We design it.
Yeah. That was a nice little addition there.
I mean, I understand.
Really sparkle.
I'm just gonna let you count them.
That's from.
I'll go and see there, but not see water.
We're doing great so far.
I heard that.
Do you know this whole area?
That's question.
I'm down. Yeah, like, well,
Fish.
they're in it all the time.
There's a one with 106 beef protons. There's a 105
Like whenever you go under a pool though, you can't see the water. It just looks like air around you. You just can't breathe it in. So I guess so.
So if you figure that out, let me know.
It just has to not explode first.
Okay, as we finish up summarizing our thoughts, who would like to stand and share the Bible verse and then your group's thoughts behind that for us? Okay, Summer is going to be our brave very first volunteer. Thank you, Summer. Yes. You don't have to stand up here if you don't want to. You can sit there. Okay. I'll scoot over there and share the spotlight.
By faith we understand that the worlds were framed by the word of God, so that the things which are seen were not made of things visible. Hebrews 11:3. We said that verse meant that we can't see atoms, but God can because He created them.
Very nice. Thank you, Summer. All right. Think you're up, Justin.
The Lord by wisdom bounded the earth. By understanding he established the heavens. Proverbs 3:19. We said God knew who he was doing by making all the elements into every object. And in doing this, we can look at this today and see how science can prove the Bible.
Very good, thank you.
Lift up your eyes on high and see who has created these things and who brings out their host by number. He calls them by name, by the greatness of his might and the strength of his power. Not one is missing. Isaiah 40:26. And we said that all the elements have names and there's no gap in the numbers between them.
Very good. All right, thank you so much for your participation today. And now we will move on to cupcake time.